Hello, my name is Danish, and I will talk about objectives and results of this project. As we all know, the first part of this project focused on designing a transactional processing system for GMC Hospital to fulfill and optimize its transactional and reporting capabilities. As we move to the second part, the primary objectives of this project were to design and develop a data warehouse to address anticipated reporting and analytical needs of the client. To achieve this, it was essential to create an OLAP cube by using integration and analysis services. Now talking about the results. With a predefined approach and lessons learned from the previous project, our team was able to fulfill all the project requirements within the stipulated time. Following the KISS strategy, which is an acronym for Keep It Simple, Stupid, we designed a simple yet effective dimensional model in order to address all the reporting and analytical requirements. We were successfully able to import data from external files such as MS Access, CSV, Excel, and SQL Server database and map it to our dimensional model using SQL Server Integration Services or SSIS. The next step was to create an OLAP cube for data analysis using SQL Server Analysis Services or SSAS. For reporting needs, we exported our data from SSAS to Excel and addressed the business questions using pivot tables and charts. For few questions, we linked our OLAP cube to SSRS, which is SQL Server Reporting Services, and generated reports. In a nutshell, using several integration and analysis services, we were able to extract data from different sources, create a data warehouse and an OLAP cube, and slice and dice the data to address business questions and create meaningful inferences.
Okay, so I'm going to talk a little bit about our approaches to development of our projects today. So we had kind of two separate aspects. So we had our team approach, which is basically we got together and we analyzed all of our project requirements when we first got them, and then we'd kind of assign roles to each other based on who had experience with what and who wanted to learn what. And then we decided, kind of based on what we knew at that point, certain checkpoints for, a somewhat iterative development process, because we would come back and check at our next checkpoint, our next meeting time, which we would meet pretty regularly. So that was kind of our plan of interacting, of tackling the projects. Now, as far as development went, we kind of just went in a consecutive manner. We just decided to take the database, get it fully completed, functioning, and then start focusing on the application after that. And so that did kind of set us back a little bit because, by the time we got the database actually completed, we had that was about 2 weeks into it. So once that was done, we were more than ready to get started on the application. So okay, so our goals, kind of our strategy for the database development. We had a couple things we wanted to do as far as our strategy was concerned. So one of the things was creating staging tables to hold our data, our original data that we were given. So we were given data from source in CSV files and Excel files, and so what we did is, instead of just uploading that directly to our database model, was we created staging tables and uploaded those to the staging tables, which we then used to populate our database, which worked out for us because we had to repopulate our database a few times, and that was a little bit easier to do from some staging tables. So we also created stored procedures and triggers to do some repetitive processes for non-application based functions. Example would be the repopulation of our database. It was a very complicated one. I'm not sure we could have just made it one big long query. Then another one would be for the item level auditing in the database. That was done through table triggers. And then we also utilized views for more complex queries. So example would be reports just created a view of these, complex, usually subqueries, and then just kind of through the application would just query those views directly, and it made that a lot easier. Okay, so our goals in app development, same thing here. We had a couple things we wanted to do. One of which was to create some shared classes to control some of the functions. The main factor here was to make sure that when we access the database that we were passing all the information that we needed to fulfill the requirement for the item level tagging, the item level auditing in the database level. The function that we needed, or the function that was running, needed us to pass a username, or it would use the system username, and that would be kind of useless. So, and then we also wanted to keep some shared values in a centralized location, such as queries and connection strings and just random values that we were all looking at, so that we had we all knew we were looking at the same thing, and also if we had to make a change, we were only going to one place to do that. We also wanted to write reusable code for future projects, so that make it a little bit easier on ourselves in the future.
Hi, I'm Ernesto Serrano from Group 4, and I'm going to be talking about the lessons we learned during the execution of this and the previous project. The first and probably the most important lesson we learned is to define and assign clear roles and responsibilities at the project planning phase. Some other important things we learned during the project are to identify and address risks that may arise at any point in the project lifecycle. These risks could arise at a late stage but could delay the project in a crucial stage. Decide on a communication platform and frequency of communication, and communicate progress and/or issues to the project sponsors regularly. Also, negotiate scope and deadlines with project sponsors if necessary. It may be that there is more room for negotiation than first assumed. Lastly, do designate a person to compile and submit the final deliverables to prevent any duplication of effort, budget time properly, and prevent potentially missing a deadline.
Okay, I'm going to show you a real quick demo of our first application. Okay, so you log in, you get your menu, and you can kind of pull up a couple of different views. As you can see, this is a little cluttered, but you can adjust the columns that you want, as well as their width and all of that good stuff. So. And as you can see, when you click on something else, it will populate all of the information over here. Same with materials, a little bit less cluttered, a little bit more clean. Let's see. There's a lot of records on this one. Requisitions, kind of same deal. Can delete items. If you go to inventory, same deal. Let's see here. Okay, so we have our reports. So we have about just three reports, all of which have the ability to export as a CSV file. Which is pretty nifty. Let's see here. Then we've also got a administration kind of window. It's mostly used for debugging, but it'll also kind of record all the steps that you take, all the things that you click, all the stuff that you do in lifetime, so that we can kind of have an idea of what's been used and what's not being used, and then if you have any problems, that's where your error messages are going to be, and it also keeps an actual log file that will pull up. And that way, if you actually have any real errors, you can take that log file and submit it back to us, and we can take care of it. So.
Hi, this is Vignesh, part of Team 4. I'm going to give a demonstration on the data warehouse. So the data from the transaction processing system needs to be loaded into our dimensions and fact tables. We have built our dimension modeling, and we have created all the tables in the SQL server. We are going to take one of the example here as water acquisition fact table. So the records has been deleted, and we make sure that it doesn't have any data. So we have populated the data into those tables using SQL Server integration services. So this is how the SQL query, this is the SQL query that populates the data from the transaction processing systems, and this is the destination where we select which table needs to be loaded, and we can execute this package so that it can load the data from the transaction processing system. So this is what our ETL jobs are going to do. 1688 rows has been loaded, and we can verify that once. Yes, so here we have select the top 1000, that's why you can see 1000 here. And once we are loaded the data, we can populate the cubes. So the cubes are used for the analysis purpose. We just need to process the cube. The cube has been built already. The source needs to be selected, and the data source view needs to be created. Once these are done, then we can prepare our cube. We can understand here like 1088 rows has been read. That means like our cube has been updated. So before that, once we will refresh. Water acquisition fact that we have created newly contains like the delivery quantity, what is the maximum delivery quantity. We can do all sort of analysis from these cubes that we have prepared. Like for example, then what delivery quantity, what is the total water acquisition quantity, what is the water delivery quantity. Corresponding ward names I'm selecting. So this gives an idea of which ward has requested how many number of items. We can do, I mean, we can even analyze using the pivot charts and tables. There are plenty of ways to make some analysis. Here we can do the same sort of analysis even here also. Water acquisition fact as the water acquisition quantity, then the delivery quantity, and we are going to select the dimension here like ward name. Yeah, so this gives an overview of like how many requests has been made by the corresponding wards. This is a quick demonstration on how the cube and the integration service that has been working, and these reports from either we can generate from the Excel or we can use SSRS to populate and get these data from.